Welcome to the thrilling end of our Griffith Observatory tour. Today, we're heading down to discover the mysteries at the outer limits of space. We'll also meet the iconic Albert Einstein, the genius of the 20th century. And for the grand finale, let's visit the Zeiss Telescope. Get ready to embark on a cosmic journey. To reach the lower level, just head left of the Samuel Oschin Planetarium. And don't miss the opportunity to capture a memorable keepsake of your visit by taking a photo against the striking Griffith Observatory banner located at the foot of the stairs. Keep going, and you'll encounter Four Winds, a panoramic masterpiece beautifully capturing the Los Angeles landscape against the backdrop of the expansive sky. Just before you reach the hallway entrance that leads to the lower level, you'll spot a remarkable sculpture on your right. It's called the Aztec Calendar Stone, or better known as the Stone of the Fifth Sun, because calling it just a calendar is a bit misleading. Take a look at the plaque on the left for a clearer explanation. The 20 symbols arranged in the ring represent the 20-day names in the Aztec 260-day cycle. To the Aztec, it symbolized the age they lived in, following four other mythical ages, each ending in catastrophic events. This sculpture is huge, 12 feet across and weighs a whopping 24 tons. It was excavated in 1790 and now takes center stage at the National Museum of Anthropology in Mexico City. But how does it also appear here at the observatory? Well, this one's a replica, just a quarter of the original size. As you stroll down the hallway, take a look to your left. There, you'll find a stunning display of jewelry on the wall. About 2,200 pieces come together to form a dazzling ribbon of time. Kara Knack, a devoted member of the Friends of the Observatory Board, spent nearly 25 years collecting these celestial jewels. Her collection helps tell the universe's story on this timeline. Above, you'll spot panels marking key moments. Let's briefly explore them. Let's start off at the beginning with the Big Bang. The universe bursts in a blazing explosion, stretching out space and time. Just a tiny fraction of a second later, the universe is as small as a compact car. In the following 3 minutes, the building blocks of hydrogen, helium, and lithium come together and mix. 400,000 years later, the universe continues to expand and cool. Atomic nuclei start capturing free electrons, and for a while, everything goes dark and see-through. There's a backdrop of intense light, resembling the fading glow of the Big Bang. It's like a curtain, and we can't see what's behind it. Gravity is at work, pulling more gas towards faint areas with cooler and denser matter. In the background, dark matter is shaping growth of cosmic structures. Eventually, these regions will come together to form a network of galaxy superclusters. Fast forward to 400 million years, gas pockets gather and collapse, forming chilly, dark clouds. Over time, these dense patches heat up. These are the birth of the first stars and the faint beginnings of galaxies, bringing fresh light, the first since the Big Bang. As these young galaxies mature, massive black holes play a role in shaping where stars cluster and how galaxies develop. About 1 billion years after the Big Bang, countless galaxies emerge as the universe grows and evolves. Among them is our Milky Way. Some of its earliest stars originate from dwarf galaxies. Their collisions eventually give rise to the spiral shape we see today. Around 1.2 billion years later, dark matter still plays a role in sculpting gas, star clusters, and galaxy groups into a grand cosmic web. At each crossroads of this web, you'll find massive collections of galaxy clusters. These superclusters are the universe's biggest structures. Here, at 1.4 billion years, galaxies collide frequently. These collisions kickstart star-making frenzies and bulk up the hefty black holes at the galaxy centers, giving birth to quasars, vibrant hotspots with massive jets at a galaxy's core. For a while, these quasars outshine all the stars in their galaxies. Let's skip ahead to 9.1 billion years, the approximate time of when our solar system was born. All the planets in our solar system, their moons, smaller objects, and interplanetary debris originate from the same birth cloud of gas and dust as our Sun. 9.9 billion years post-Big Bang, collisions are still frequent as chunks of material swirl around the Sun, coming together to shape planets. These crashes play a crucial role in the construction of celestial bodies. The marks we see on the moon are reminders of the last significant clashes during the planet-forming days, aligning with the creation of Earth's oldest rocks. Life finally makes its debut on Earth, 10 eons after the Big Bang. These early pioneers are tiny ocean-born microbes, and they find their home in the welcoming seas where life flourishes. 3 billion years after life's first appearance on Earth, all creatures still call the ocean home. Then, something incredible happens. The seas teem with a vibrant ray of sturdy beings. These creatures will one day leave behind their shells as some of our earliest fossils. We're now 13.35 billion years post-Big Bang. Life on Earth takes a bold step. Amphibians, along with insects and plants, venture onto dry ground, marking the start of a new chapter. They conquer this uncharted territory and pave the way for the evolution of diverse life forms. Even at 13.63 billion years after the Big Bang, new stars come to life within the gas and dust clouds of our Milky Way. One remarkable example is the Pleiades, a cluster of young, fiery stars found in the Taurus constellation. These stars started to twinkle just as the dinosaurs went extinct. Meanwhile, the earliest mammals are busy adjusting to our planet's changing climate. The Orion Nebula, located 1,350 light-years from Earth, nestles some of the newest stars in our Milky Way galaxy, many of them amongst the very clouds that brought them into existence. These clouds are also where the raw materials for planets come together, and it's possible that some of the stars in this nebula are in the early stages of building their own solar systems. Can you believe that all of this is still happening? Even after 13.69 billion years, roughly 3.6 million years ago, one of our early relatives left a footprint in newly fallen volcanic ash near Lutoli, Tanzania. However, it would take another million years before humans started using stone tools. Finally, 13.7 billion years after the Big Bang set the universe in motion, a human stands on the moon's surface, leaving a footprint. From the explosive birth of the universe to the silent steps on the lunar surface, we've come a long way. At last, we're arrived at the edge of space. From this mezzanine, you'll get a unique view that connects our earthly perspective with the cosmos. There are samples from space and our ventures beyond Earth that will bring the universe a little closer. Here we have the California Meteorites exhibit. Meteorites can be discovered all over California, but a lot of collectors head to California's flat, dry lake beds. Here, the fallen rocks often remain visible and untouched for ages. The large dots on the map to the right represent the meteorites from California in the Griffith Observatory's collection, while the smaller dots mark other discoveries in the state. Back in 1998, farmer Ben Howard was tilling his land near Sacramento when his plow hit something massive. It was a 183-pound meteorite that happens to be the biggest stony meteorite ever discovered in California. When Robert Varish, a meteorite hunter, found 2 small stones in the Mojave Desert, these rocks were once part of a Martian lava flow, dating back around 180 million years. While countless meteorites rain down on Earth each year, tracking them down is no easy task. They scatter everywhere, and if they land in the ocean or vanish into forests and fields, they might be gone forever. The prime meteorite hunting grounds are places where they stand out in the landscape. They include the deserts of Australia, Africa, and the Middle East, the frozen expanses of Antarctica, and the dry lake beds of California and the American Southwest. In the icy Antarctica, meteorites can be concealed beneath layers of snow for years. Expeditions head out every summer to search for these hidden treasures. However, not every peculiar rock is a meteorite. Meteorite hunters rely on various factors to tell if a find is truly from space. Meteorites aren't smooth or hole-ridden like regular rocks. Stony and iron meteorites might have a glossy, melted appearance, often marked with dents. An iron meteorite will respond to a magnet, and some stony ones are a bit magnetic too. Compared to typical rocks, iron meteorites pack more weight into their size. In our solar system, the surfaces of every planet and moon display evidence of meteorite impacts. This exhibit explores the impact of meteorites, revealing how these collisions have shaped the landscapes of celestial bodies. In our planet's early days, it faced constant showers of such collisions, although most of these ancient craters have either eroded or been covered by natural processes. Only a few remain visible. In contrast, on the Moon and other airless worlds, they remain preserved, showcasing craters of all sizes. When a large object from space strikes Earth, the sheer force and pressure of the collision vaporize parts of the incoming object and the ground. It creates an explosion that excavates the crater, melts the surrounding rock, and scatters fragments far and wide. The surrounding rock melts due to an intense amount of heat generated. Some of this molten rock flows, while some are shot into the air alongside other ejected rocks and meteorite fragments. As these airborne globs of hot liquid rock fall back to Earth, they cool into fascinating shapes. These cooled bits of melted Earth are called tektites, and each one is like a unique time capsule of the conditions that created it. Tektites are scattered across just a few spots on our planet. You can find bedeiosites in Texas, Libyan desert glass across the northern African deserts, and Maldivites in the Czech Republic and neighboring country. Now imagine capturing shockwaves in stone, and that's exactly what shatter cones do. When a powerful impact strikes layers of bedrock, immense pressure causes the rock to fracture, forming distinct three-dimensional cone shapes. These cones' tips direct us right back to where the impact originated. Life on Earth is surely filled with its share of surprises, but some of the most astonishing moments are brought to us by the cosmos itself. In 1954, an asteroid fragment crashed through a home's roof in Alabama, bounced off the floor, and struck in Hodges while she was napping on her couch. This event made her the first documented person in history to be hit by a meteorite. It makes you wonder, can mass extinction events happen, triggered by asteroids? Well, 65 million years ago, a catastrophic event did occur, leading to the extinction of the dinosaurs and many other creatures. It's believed that a colossal asteroid or comet crashed into the ancient shores of Mexico's Yucatan Peninsula. This impact packed the punch of a 100 million megaton bomb and created a colossal crater spanning 60 miles wide. The collision kicked up immense amounts of dust, blocking out sunlight and causing temperatures to plummet. Plant photosynthesis came to a halt, creating harsh conditions and food shortages, ultimately contributing to the demise of countless Earth's animals. If you've ever wondered where meteorites come from, we've got an exhibit here that'll answer all your questions about their origins. Most meteorites come from asteroids. Many of them orbit through interplanetary space, and most are found between Mars and Jupiter in the asteroid belt. Asteroid belt objects are not a threat to us because they tend to stay in their orbits around the Sun. Occasionally, a collision knocks asteroids toward Earth. Fortunately, that is a rare occurrence. Tiny chips of asteroids, however, fall through our atmosphere all the time. Back in 1969, a bright blue-white fireball shot across the morning sky, causing a huge explosion when it broke into pieces in our atmosphere. This explosion woke up the people of Pueblo de Allende, who started collecting the fallen pieces. To everyone's surprise, they were made of the same stuff as the inner planets and asteroids, giving us a peek into what the early solar system was like. Meteorites come in a fascinating variety of types. Most are stony, with minerals similar to Earth rocks. Some even have chondrules, which are some of the oldest materials in the solar system. There are stony iron meteorites, which have beautiful olivine minerals trapped in iron. And there are iron meteorites that come from the heavy iron cores of asteroids. To understand these meteorites, it's essential to explore how asteroids are created. Imagine countless chunks coming together in the early days of our solar system to create these big space rocks. When some of the largest asteroids got hot, iron sank to the middle, forming cores, while lighter rock floated up to make layers on the surface. And there are some asteroids that are like volcanoes, with magma flowing from the inside to the surface. Now, there are asteroids that haven't been messed with by collisions, and they might have a core, a middle layer, and a surface. If you've ever caught a glimpse of a shooting star, you've witnessed meteor flashes in action. This is because the small bits of it burn up as they rub against the air molecules in our atmosphere. The tiniest space particles come from comets. As they orbit the sun, comets shed this dust along their paths. When Earth crosses these dust trails, the material enters our atmosphere and vaporizes. The particles create gentle, graceful meteors in what we call meteor showers. A comet's core is made of ice and dust, and it formed in the early days of our solar system. This core is mostly water ice, with a bit of methane and ammonia mixed in. The dust particles in comets are tiny, really tiny, ranging from the size of a grain of sand to even smaller than the dust bunnies on your furniture. So, as you watch meteors streak across the night sky, remember that they have incredible tales to tell about their journey from the vastness of space to our own little blue planet. Now, let's check out the cloud and spark chamber on the other side of the mezzanine. In the cloud chamber, scientists can actually see and track charged particles like electrons, protons, and muons in action. And how does it work exactly? Well, the chamber is filled with a special alcohol vapor. When a charged particle zips through the vapor, it forms visible clouds or streaks right along the particle's path due to condensation of the now ionized vapor. With this setup, researchers can figure out what these particles are up to and where they're coming from, whether it's cosmic rays, nuclear reactions, or something else entirely. The spark chamber is a specialized device used in particle physics to detect and track high-energy particles, particularly muons. To make it work, the chamber must be loaded with gases like helium and neon. When an energetic particle zooms through the chamber, it ionizes the gas atoms. Now, if this particle's path meets all three sensors inside the chamber, it creates sparks along its path. You can actually see and hear these sparks, which helps scientists track the path and learn all about it. And just like spark chambers help us uncover the secrets of particles on Earth, studying the moon can reveal its own fascinating mysteries about our celestial neighbor. The precious lunar rocks astronauts who ventured to the moon brought back weren't just souvenirs. They held the key to understanding the moon's connection to Earth and offered insights into our solar system. They collected a massive 842 pounds of rocks, pebbles, core samples, and dust during 6 missions, making it the first time we ever brought samples from another celestial body. Now, the moon itself is a world unlike any other. Its surface is marred by craters, blanketed in a layer of dust and devoid of air, liquid water, and life. The moon's gravity is only 1/6 of Earth's, which means you can leap around on the surface. However, surviving on the moon is challenging. Its days and nights are much longer, with nearly 14 days of continuous sunlight followed by an equally long night. Temperatures vary from scorching hot to freezing cold. That's why astronauts need super high-tech spacesuits to stay safe and mobile on the airless lunar surface. These suits supply them with oxygen, keep them cool, provide shade from intense sunlight, and even weigh them down to help them explore the moon's harsh environment. Finally, we have arrived at the Gunther Depths of Space exhibit's floor. This stellar exhibition offers a fascinating glimpse into the wonders of our universe and our solar system. Our universe appears wonderfully three-dimensional. Yet, when we simply glance upward at the sky, it seems unexpectedly flat. Even the remarkable big picture, a mind-boggling 2.46 gigapixel cosmic image crafted from telescope data just for Griffith Observatory, gives off that same flat vibe. This illusion happens because, from our vantage point on Earth, the sky looks like a giant celestial dome, almost as if someone painted a breathtaking mural above us. To make sense of the vast canvas before you, you'll find a life-size bronze statue of the 20th century's most famous scientist, Albert Einstein, sitting on a bench with his right index finger extended about a foot from his face. It's as if he's measuring the expanse of the night sky showcased in the big picture. His statue provides a human touch to help you grasp the enormity of the cosmos. But what if we were to send a postcard from our place in the universe? This is not just any postcard, it's a cosmic postcard with your precise location in the universe. You see, our cosmic address isn't your typical street and city name. It's a multi-level description of our place in the vast expanse of space. First, there's the familiar Los Angeles, our bustling city. Earth, our home, a unique, life-sustaining planet, enveloped by a protective atmosphere. Beyond Earth, our neighborhood extends to the local group, home to galaxies like our Milky Way and the Andromeda Galaxy. Now, let's zoom out even farther to the vast universe itself, filled with countless galaxies scattered across the cosmos. The light from some of these galaxies has been traveling for more than 2 million years to reach us, providing a glimpse into the distant past. So, as you explore the universe, remember that it's not just a simple mural on the celestial dome above. It's a complex, multi-layered masterpiece that stretches across unfathomable distances and eons of time. On a clear summer night, if you gaze upward, the part of the Milky Way visible from Earth extends high across the sky. It is just one of countless galaxies in the universe, yet it's the only one we can truly explore from the inside. Our solar system is located approximately 26,000 light-years away from the center of the Milky Way. Have you ever wondered where our little corner of the universe is located? Well, we call the Orion Arm, also known as the local spur, our home in this vast galactic neighborhood. Now, let's shift our focus closer to home, to our very own solar system. Within this gallery, we'll explore the planets. Our innermost quartet of planets are compact and rocky. As we journey outward, we encounter colossal gas giants and frigid ice giants. Can you guess what made some rocky and others icy giants? Well, in the solar system's early days, the sun's blazing heat vaporized ice and gases. With this in mind, let's start our journey with the sun's fiery neighbor. Mercury is a planet of contrasts. Imagine a searing heat that could melt solid steel or icy cold that could shatter it, all on the same planet. Its barren landscape, marked by countless craters and fractures, might remind you of our moon's long-lost twin. However, there's an intriguing twist. Long, jagged cliffs stretch across its surface, revealing the signs of a shrinking and cracking process as its iron core gradually cools. Here, we have Venus, a planet of immense atmospheric pressure and scorching heat. Its unique landscape lies hidden beneath thick clouds of sulfuric acid, shaped by volcanic forces. The planet's volcanic activity has left its mark, creating peculiar features such as towering lava peaks, pancake-like domes, and intricate arachnoid patterns. Uninhabitable by any known life forms, Venus posed a challenge for exploration. However, carefully designed spacecraft equipped with diamond and sapphire windows were able to investigate its mysteries. Our familiar home, Earth, is a planet of constant change. Earth's surface is shaped by tectonic plate movements, volcanic activity, erosion, and asteroid impacts. The crust consists of numerous plates carrying continents and ocean. These plates slowly shift over time. Colliding plates create mountains, grinding plates cause earthquakes, and plates moving apart result in molten material rising to fill the gap. Our understanding of the Earth's interior comes from studying seismic waves generated during earthquakes. While we experience frequent earthquakes, more major ones can lead to significant shaking, equivalent to the release of energy from thousands of nuclear bombs. They can cause landslides, tsunamis, structural damage, and aftershocks. California, with the San Andreas Fault, is a region frequently affected by earthquakes. A monitoring system, including Griffith Observatory sensors and global positioning satellite receivers, helps predict potential earthquake activity. Notable historical earthquakes include the 1906 San Francisco earthquake, which resulted in widespread destruction and casualties, and the 1994 Northridge earthquake, a powerful event that caused significant damage but was lessened by strict building codes. Earth is a place of diverse environments, teeming with life. We know this planet better than any other, and it's our reference point for understanding the rest of the solar system. In our quest to understand celestial movements, humans have developed tools to replicate planetary motion. For example, planetarium projectors allow viewers to explore the universe through animated simulations. The Samuel Oschin Planetarium offers an immersive, realistic experience with its star projector and video system. Mars, the world next door, may bear some resemblances to Earth, but it is greatly different. This dry and dusty desert planet is covered by a thin carbon dioxide atmosphere and experiences extreme temperature variation. When we explore the red planet, we encounter a deserted and quiet world. However, its canyons, volcanoes, craters, and floodplains hint at a more active past. One remarkable feature on Mars is Valles Marineris, a vast canyon system. It originated from a series of ground faults with tectonic activity and erosion sculpting this rift. It is 4 times deeper than the Grand Canyon and wider than the entirety of North America. As we venture forth into the solar system, our journey continues to its outer reaches where we encounter Jupiter, the largest entity in our solar system. Jupiter is a gas giant with high-speed winds that shape its cloud layers and drive massive whirling windstorms across the planet. Within its hydrogen-filled atmosphere, ammonia ice crystals swirl, creating a dynamic environment. The heat rising from the active interior, combined with its rapid rotation, generates ferocious winds that blow in opposite directions. These wind currents mold Jupiter's clouds into distinct belts and zones, giving rise to colossal storms that sweep across the planet's surface. One of Jupiter's most famous features is the Great Red Spot, a long-lasting hurricane-like storm. It is often larger than our entire Earth and might have originated as a cluster of smaller storms. Jupiter is not alone in its orbit as it hosts many moons, behaving much like planets orbiting a star. The innermost of these moons contribute to Jupiter's faint, dusty rings. Among these moons, the 4 largest stand out. Io, a fiery moon with molten sulfur lava flows and sulfur gas spewing volcanoes. Europa, the water world with a smooth ice layer covering a deep, salty ocean beneath. Callisto, a moon marked by a heavily cratered surface concealing layers of rock mixed with ice and a liquid ocean above a compressed ice rock core. And Ganymede, a world hiding a rocky ice interior beneath a crust riddled with grooves, ridges, and impact craters. Across our solar system, planets with atmospheres constantly generate storms. While we are familiar with turbulent weather on Earth, the outer planets also have highly active weather systems. Saturn, the ringed world, is the jewel of the solar system with ice particles forming its intricate set of rings. This gas giant emits clouds of ammonia ice crystals from the depths of its atmosphere. Saturn's ring system extends almost 300,000 miles from the planet's cloud tops. The ring particles, spanning the range from tiny dust grains to icy boulders, are shaped into distinct ringlets by Saturn's inner moons. The moon Iapetus possesses 2 strikingly different faces. One side displays a bright cratered landscape while the other is adorned with a mysterious dark red coating. This coating might be the result of methane seeping from beneath Iapetus's surface, or it could be material collected from another moon's ejections. Notably, Saturn is not the sole member of the planetary ring club. Jupiter, too, is encircled by a stream of dust originating from its inner moons. These rings, if not continuously replenished with new dust from the moons, would be obliterated by radiation and bombardments in a mere 1,000 years. Saturn's glittering rings, as well as the ring systems around Uranus and Neptune, were formed from shattered remnants of nearby moons. It's even possible that Earth had its own ring of debris for a brief period, less than a century following the formation of our moon. Uranus, the sideways planet, is a unique world in our solar system, standing on its side with a thick atmosphere that experiences uneven heating from the sun. A soft, pale blue-green hue defines Uranus, hidden beneath a methane haze that conceals its turbulent atmosphere and gives the planet its pastel appearance. Its tilt and unusual rotation were likely the result of a huge impact from a planet-sized object in the past. This encounter literally knocked Uranus over, setting it apart as one of the most intriguing members of our solar system. Uranus rolls on its side for a lengthy 84-year orbit around the Sun, resulting in unusual seasons. For half of its orbit, one pole enjoys constant sunlight, experiencing an endless day that lasts the entire summer season. Meanwhile, the opposite pole remains in perpetual darkness, enduring a continuous night throughout the winter. Neptune, the distant ice giant, resides at a distance of about 2.78 billion miles from the Sun, a massive 30 times farther than of Earth. Neptune's stormy atmosphere is a force to be reckoned with, featuring the fastest winds in our solar system. While the outer appearances of gas giants like Neptune suggest all gas and no substance, they actually possess a complex internal structure. Each of these giants boasts a solid core, layers of ice, and frigid oceans of liquid hydrogen, hidden beneath the surface that we see. One of Neptune's intriguing moons, Triton, showcases the phenomenon of ice volcanism. This cold satellite stands as one of the chilliest places in the solar system, featuring a textured surface like that of cantaloupe skin, shaped by the melting and refreezing of ice. Geysers shoot forth nitrogen gas across Triton. Pluto, the frontier world, exists on the fringes of the solar system, a remarkable 3.7 billion miles away from the Sun. Alongside its moon, Charon, Pluto displays a surface of frosted methane ice etched with puzzling dark features. As we venture further into this distant frontier, we uncover the Kuiper Belt, a region that was once considered the solar system's farthest edge. However, we now know that Pluto and Charon are not isolated outposts but are part of the icy worlds within the Kuiper Belt. Icy objects like Sedna challenge Pluto's status as a planet and expand our perception of what defines a planet. They might very well be the remnants of our solar system's birth cloud, preserving its ancient history for us to unravel. After a day of exploring the fascinating exhibits, both mentally and physically, there's no better spot than the cafe at the end of the universe to relax and refuel. You can take a seat inside or choose to enjoy your meal on the Sunset Terrace, where you can soak in views of the city and even catch a glimpse of the iconic Hollywood sign. To wrap up our tour, let's head to the rooftop dome on the east side of the building, where you'll find the remarkable Zeiss Telescopes. These telescopes are perfect for stargazing at night and provide breathtaking views of the moon, planets, and the brightest star. When there are special celestial events like Halley's Comet or comets like Hale-Bopp, more people prefer to use this telescope than any other in the world. Each clear night, this Zeiss telescope can host up to 600 visitors. An experienced telescope demonstrator from the observatory will be there to guide you as you peer through the eyepiece of the 12-inch Zeiss refractor, ensuring you have an unforgettable stargazing experience. On a special note, the Griffith Observatory Foundation is offering 2 unique trips to witness the 2024 total solar eclipse, a rare opportunity in North America until 2045. For more information, visit the official website. Don't miss this chance to be part of a celestial spectacle. And that wraps up our tour series of Griffith Observatory. If you enjoyed the experience, we appreciate your support through liking, subscribing, and sharing your thoughts. Let us know which destination you'd like us to explore next, and stay tuned for our next video exploring the California Science Center.